Okay, so we are on to chapter 10 with the factorial ANOVA, and it is just going to carry on from our chapter 9 work with the one-way ANOVA. So we're going to have more than one F that we're going to be working with. We had a one-way ANOVA, which is one factor, one IB, and now with the factorial ANOVA, we have more than one factor, more than one IB, which is going to lead to multiple Fs. Our Fs are still going to be the same. It's going to be a ratio of between group variance over within group variance. We can also call within group variance error. When we're identifying the F ratio, we want the F ratio to be greater than 1. If it is 1, that indicates that any variance going on between my groups is identical to the variance going on within the groups. If I have an F less than 1, that indicates any variance going on between my groups is completely washed out of lots of variance going on within my groups. And again, ideally, you want an F larger than 1. Some assumptions for our ANOVA. Factorial ANOVAs, we are going to stick with the most basic, which is a two-way factorial ANOVA. Two-way, identifying there are two factors or two IVs. We do need our population to have a normal curve. If we are doing a between subjects design, we need equal variances. We talked about equal variances last week in chapter 9 in the one-way ANOVA. We also talked about equality of variance, equal variances with t-tests, with the independent t-test. And so those are some of our assumptions. Again, this is a more complex ANOVA. It's called a factorial ANOVA because you have more than one factor or more than one IV. The beauty of it, it's like you're running multiple studies at once. So if I'm interested in the impact of gender and types of exercise on stress relief, I could, instead of running one study on are there gender differences with stress or are there exercise differences with stress, I put them all in one study. So I'm able to identify, is there a main effect for gender? Is there a main effect for exercise type? Or is there an interaction? Does a type of exercise work better for males versus females? That's all things we get with the factorial ANOVA. With a two-way factorial ANOVA, we will have three Fs, and we're going to be going over those in a little bit more detail. But again, your three Fs would be the main effect of factor 1, the main effect of factor 2, and the interaction. When we're going through, again, that idea of a main effect of factor 1 and a main effect of factor 2 is almost like you ran two one-ways. But again, in the world of statistics, it's better to combine all those things in that one study so we are able to see that interaction. In a factorial design, again, you're taking that information all at the same time. So it is an all-in-one study, which makes it much more efficient. And then you get the bonus to identify, is there something unique happening at the level of one IV that's dependent on or connected to the other IV? So for example, with my gender and exercise on stress study, is there one type of exercise that might be more beneficial for one gender compared to another? When we're going through again, when we talk about our two-way ANOVA, when we have our three Fs, sometimes we're going to see it's going to refer to as columns and rows. And columns and rows is where you present that data. And you're going to see more of why that's called, but you can think of the column as a main effect. You can think of the row as the main effect, and the interaction is our new bonus. Again, all of these Fs are going to follow those same ideas of between group variance over within group variance. So for our main effects, our rows and our columns, it's going to be analogous to our one-way ANOVA. And then the logic of the interaction is now going to look at those unique conditions across all of our factors or both of our factors. So I wanted to share a real life example with you. So I'd like you to take a moment to pause the video and go ahead and click on the link for the NPR story. It's a very quick 1-minute link. This story is going to talk to you a little bit about doctors questioning parents' ability to dose their children with proper dosage for medication. Although the researchers did not use an actual factorial ANOVA, which is very sad, that's what they should have done, they did use a design that had two different variables. And those two variables, or those two factors, or those two IVs, were dosage and modality. For this two-way ANOVA, we can call it a 3x3 design. We can call it a 3x3 design because factor 1 dosage had 3 levels, and factor 2 modality had 3 levels. So the nice thing when you see a study that says a 2x2, which means the number, or if it's a 2x2x2, a 2x2x2 is 3 factors, each having 2 levels. A 2x2 is 2 factors, each having 2 levels. So this is a 3x3, 2 factors, each having 3 levels. So they're looking at dosage, how much, 2.5, 5, or 7.5 milliliters, and then they're looking at modality. How are they serving those children those medications? Is it a small syringe, is it a big syringe, or is it a medical cup? And then they were interested in looking at and narrowing down error in dosage. So I'm going to go ahead and show you their actual study results and just talk a little bit briefly about these, and then we're going to dig deeper into the Factorial ANOVA. So just looking across this graph, again, you understand p less than 0.05 is excellent. So we've got a p less than 0.05 here, we got a p less than 0.05 here, we have new differences there. These are looking at, so this is across your dosage, those are my 3 different dosages, and then these are my 3 different modalities: cup, small syringe, big syringe, cup, small syringe, big syringe, cup, small syringe, big syringe. So looking across these 3 groups, if I were to even out these bars, even out these bars, even out these bars, and compare those 3 bars, would I see differences? And I would say yes, we do seem to have a main effective dosage. But then I can dig further and ask myself, well, is there and also a main effective modality? So do I see differences when I even out my black bars, when I even out these gray bars, and when I even out those last gray bars? When I even those gray bars out, I do see differences. So I would have had a main effect of modality. But what's most important here is, do you see an interaction? Is something unique happening with regard to specific dosages and modalities? And yes. Oh my gosh, parents really are messing up using a cup for 2.5 milliliters. And that actually is a small amount to put in a little cup. And so the biggest takeaway is parents can overdose. They're making mistakes. And the best thing they should do is use a syringe. Good take-home message when you're dosing children, young children with medications. And we're going to talk more about this. So, been a real study that connects very well to Factorial ANOVA, even though sadly the researchers who published the study didn't do the Factorial ANOVA, but lends itself nicely. All right, so let's take a deep breath, and I want you to pause for a minute and ask yourself, what do I know so far about Factorial ANOVA? And then we're going to move forward. Okay, so now I'm going to talk to you about, digging a little deeper. How do we identify these things for main effects and interactions? So I'm going to introduce some new terminology to you. So a main effect, again, is analogous to the one-way. It's basically a repeat of Chapter 9. When we want to look at main effects, when we're dealing with more than one factor, we're going to look at something called marginal means. Marginal means are kind of ignoring the other factor and looking at the overall effect for that one factor, for those 2 levels of that one factor, if we have a 2x2 design. If I'm interested in looking at interactions, I'm going to look within the cell, and when I'm looking at the cell means. All right, so I'm going to show you those and connect with that terminology in a minute. So interaction effects, basically I'm seeing, is there something unique within a particular level of one factor that's interplaying with that other factor going on? So the effect of one variable that's measured is different across the levels of the other variable. And we're going to see that nicely when we look within those cell means. All right, so this is an example from your book. So I do encourage you to go into your book in Chapter 10. And they've connected with this study. So this study looks at 2 different factors. Factor 1, test difficulty, easy test, hard test. Factor 2, a personality variable. Are you a highly sensitive person or not? I'm going to give you some questions if you want to take a measure of where you're at with that. And then, so that 2x2 design, again, factor 1, task difficulty, 2 levels. Factor 2, sensitivity, 2 levels, leads us to have 4 unique cells. So these are my cells. Inside of those are each your cell means. The mean for not high sensitive easy task difficulty was 2.43, hard not high 2.56, high sensitivity easy task 2.19, task difficulty for hard 3.01. And these mean numbers are your mood, level of negative mood. So when I'm interested in looking at interactions, I'm going to look within these cell block means. If I'm going to be looking at my marginal mean. So my marginal mean for not high was 2.495, which is getting it from averaging out my 2 groups. My marginal mean for high is, again, adding these 2 up divided by 2, and I get 2.6. If I'm looking at, is there a main effect for sensitivity, I'm comparing these 2 numbers. Likewise, if I'm looking at, and this would be a main effect of rows, because this is my factor that's in my row. If I'm interested in a main effect of task difficulty, I'm going to compare these 2 marginal means. Again, this marginal mean comes from averaging out these 2. This marginal mean comes from averaging out these 2. If I compare these 2 numbers, do they seem very different? No, I do not have a main effect of sensitivity. If I compare these 2 numbers, do I have a main effect of task difficulty? No, I don't. So if I had run each one of these separate, I would have had null findings. However, that's not what Aaron and colleagues did. They ran them as a factorial study and put them all together. So again, just for fun, if you want to see how your mood is, go ahead and measure and answer these questions on a 1 to 7 scale. If you have a high number, then you might have been in that highly sensitive group. So again, main effects kind of compare, again, collapsing across the groups and looking at, is there a main effect, kind of ignoring the other factor. Now our interaction is where the interesting thing happens. So interaction, you need cell block means for interaction. So I'm comparing these numbers. One of the best ways to compare those numbers is actually, I think, to look at the graph data, to look where do these fall, do they intersect and connect in some way. So again, an interaction is going to look at all 4 conditions, regardless of what factor they were a part of. And so when I look at my graph, this is the same data for test difficulty by sensitivity. I can see there is an interaction going on here, and that's placed right here. So there do appear to be differences for highly sensitive people. They get more frustrated on harder tasks. People who are not highly sensitive seem to respond similarly. So you can see that with that basic interaction. When we have interactions, it's important to note that is the highlight of your study. That's where you're going to focus your interpretations of. If you have a significant interaction and significant main effect, you're going to interpret your main effects cautiously. In this Aaron study, there were no main effects. There was just that interesting interaction. However, if we go back to our study I started with a medical study with dosage and modality, we would want to focus on the interaction. And so we do see an interaction here, and what appears is it's the cup that's driving the errors across these differences in these 2 groups, though if you have larger dosages, it doesn't matter what type of modality you put the medicine in for the child. So again, my interaction, regardless of what main effect findings I have, your interaction is what's going to hold the gold and what you're going to focus on. I am going to have a part 2 video that's going to go over how do we decipher an ANOVA table. So this is the ANOVA table. It is an enhanced ANOVA table from the ANOVA table you had for the one-way because we have 3 Fs. So this is going to be my next video. I'm going to close and instead of talking about all those interactions and how we figure out, that's going to be the next video. I am going to say we still calculate effect size or eta squared or r squared, still interpreted the same way. There are formulas to do that, though I'm not going to ask you to calculate the effect size or r squared formulas, but I am going to ask you to interpret. So this is a very important piece of information here. Again, power is always important to know. You always need to figure out your sample size to figure out your power. There's also ways to get way more complex within the two-way ANOVA. So there can be a three-way ANOVA. Again, a 2x2x2 is a three-way, each one having two levels. There's also completely repeated measures ANOVA, or all within subjects. There's also the mixed, where you have one between subjects and one within subjects.